China just built ASML's worst nightmare. Somewhere in a boardroom in Veldhoven, Netherlands, someone had to explain to investors why their stock just lost 8% of its value in a single trading session. And the explanation had nothing to do with earnings, nothing to do with a product recall, nothing to do with a scandal. The explanation was one sentence buried in a report from an American tech outlet. A little-known Chinese company had figured out how to build the machine ASML spent 20 years and $10 billion perfecting. That's not a rumor. That's not speculation from some anonymous account online. That's a confirmed mass production reality now, according to Reuters, Bloomberg, and CNBC, all reporting on the same story within days of each other. And when the news landed, it didn't just hurt ASML. Applied Materials dropped, Lam Research dropped, KLA Corp dropped. The panic jumped oceans, hitting chip equipment stocks in Japan and South Korea before the US markets had even finished digesting it. This is the story of how China built the one thing ASML genuinely feared, why the fear is real even though the threat isn't what you think, and what happens next, in a race that just got a lot more complicated. To understand why this rattled an entire industry, you have to understand what ASML actually is, because most people have never heard of this company despite it being arguably the single most important company in the modern world that you can't buy a product from directly. ASML makes the machines that make the chips that run everything, not just your phone. Every AI data center, every fighter jet's targeting computer, every electric car's battery management system, every hospital MRI machine, all of it eventually traces back to a chip. And every one of those chips was printed using a lithography machine. And for the most advanced tier of that technology, ASML is the only company on Earth that makes one that works. Not the best one, the only one. Intel can't build it, Samsung can't build it. TSMC, the company that manufactures Apple's and Nvidia's most advanced chips, doesn't build its own lithography tools either. It buys them from ASML like everyone else. That's not a market-leading position. That's a total monopoly on a piece of physics-defying engineering that took the company 2 decades and help from Intel, TSMC, and Samsung themselves just to make commercially viable in the first place. And it only started turning a real profit around 2018 or 2019. So when we say China built ASML's worst nightmare, we need to be precise about what that phrase actually means. Because there's a version of this story that's pure clickbait exaggeration, and there's a version that's genuinely important. And the honest story lives somewhere in between. China has not built a machine that competes with ASML's most advanced technology. Let's get that out of the way immediately, because if you watch this whole video expecting to hear that China caught up to the cutting edge, you're going to be disappointed. And frankly, so would every credible analyst covering this story. What China actually built through a state-backed company called Shanghai Aishengna Electronic Technology Group is a working immersion deep ultraviolet lithography machine known in the industry as immersion DUV. Now, this is one tier below ASML's most advanced EUV machines, but it is still an enormously important tier because immersion DUV is what makes the vast majority of chips in the world today, the ones running in your car, your laptop, your router, industrial machinery, and huge portions of memory chip production globally. This isn't the frontier, but it's the backbone. And here's why that backbone matters so much to the fear narrative. According to reporting from The Information, later confirmed independently by Reuters, Aishengna didn't build this from a blank slate. It absorbed engineering teams from a Shanghai startup called Yuliangsheng, which had spent roughly a year quietly testing DUV prototypes, along with additional talent pulled from Shanghai Microelectronics Equipment, the company that's been China's longest-running, if largely unsuccessful, attempt at domestic lithography. And here's the detail that makes this whole story click into place. Yuliangsheng itself is affiliated with SiCarrier, a chip equipment maker with financial backing tied to Huawei. So this wasn't one genius team solving an impossible problem overnight in isolation. This was years of scattered, quiet Chinese semiconductor efforts, several of which had been running under the radar since well before the current wave of export restrictions even began, finally consolidating into a single functioning production line. China didn't build this in a garage over a weekend. It assembled it, piece by piece, out of talent and technology it had been accumulating for years, and the outside world simply wasn't watching closely enough to see the pieces coming together until they already had. The actual production numbers are where this story gets its real texture, because the headlines made it sound like ASML had a rival overnight, and the reality is far more modest, at least for now. Aishengna is targeting production of about 5 of these machines this year, scaling to roughly 20 next year. ASML, by comparison, said it plans to build around 130 immersion DUV machines in 2026 alone, with an additional 30% planned for 2027. Run the math and you get something like 170 machines from ASML against 20 from Aishengna in the same rough time window. That's not parity. That's not even close to parity. A columnist writing from Liaoning Province, cited by Asia Times, was refreshingly honest about this from the Chinese side of the conversation, stating plainly that China's homegrown 28-nanometer DUV lithography machine still lags roughly 4 generations behind what ASML currently sells, with performance closer to what the Dutch company was producing about 15 years ago. Stefan Hori, head of equity research at ODDO BHF, told CNBC that what China achieved could be limited to the very low end of chip manufacturing, and that the initial excitement deserved, in his words, a pinch of salt. So, if the gap is this wide, why is this ASML's actual worst nightmare and not just a minor footnote that got overblown by panicked traders? Because markets don't price where a threat is today. They price where a threat is heading, and the trajectory here is the part that should genuinely worry anyone who thought China was permanently locked out of advanced manufacturing. Analysts at SemiAnalysis put it precisely when they told CNBC that tool performance, the difficulty of scaling actual manufacturing of the machine itself, the surrounding supplier ecosystem China still largely lacks, and the economics of competing against ASML machines that are already fully depreciated all stack up against Chinese DUV right now. But notice what they didn't say. They didn't say it's impossible. They said it's currently disadvantaged on multiple fronts simultaneously, which is a very different claim than saying the door is permanently sealed. And that's exactly the nightmare scenario for ASML, not that China caught up this year, but that China has now proven, conclusively and publicly, that the lithography bottleneck the entire Western strategy was built around is not actually an unbreakable wall. It's a very tall wall that took a very long time to climb, and China just proved it can climb it. Let's talk about why that wall was assumed to be unbreakable in the first place. Because the reasoning behind ASML's monopoly is honestly one of the most fascinating supply chain stories in modern manufacturing, and it explains exactly why the immersion DUV breakthrough matters, while the EUV gap still doesn't. ASML's dominance was never really about one company being smarter than everyone else. It was about ASML being the central hub of an irreplaceable web of ultra-specialized suppliers spread across multiple countries. A web that took literal decades to weave and that nobody else has managed to replicate end to end. The mirrors inside an EUV machine, manufactured by the German optics company Zeiss, are polished to a level of precision where if you scaled one of those mirrors up to the size of Germany itself, the tallest imperfection on its surface would only be about a millimeter high. The light source technology inside these machines, which involves superheating droplets of molten tin with a high-powered laser to generate usable extreme ultraviolet light, took a separate American company the better part of 2 decades to get working reliably. ASML's real product was never the machine. It was the coordination of an entire continent-spanning ecosystem of impossible engineering into one final assembly line in the Netherlands. That ecosystem, for EUV specifically, does not exist inside China's borders yet, and building it isn't a matter of throwing money at the problem, because you can't buy institutional expertise that took Zeiss and other suppliers generations to accumulate. Immersion DUV, while still difficult, sits on a much older, more distributed, and more replicable supply chain, which is exactly why it was crackable first. Now, let's talk about the money, because this is where ASML's fear becomes very concrete and very board meeting real, rather than just abstract industry anxiety. In the second quarter of this year, China accounted for roughly 14% of ASML's total net system sales, which came in around 6.6 billion euros for the quarter. Do the math on that percentage, and you're looking at somewhere close to 924 million euros, roughly $1 billion, tied to Chinese customers in a single 3-month window. That's not a number that sinks a company overnight. ASML is still an enormous, profitable, well-capitalized business with customers across the entire globe, but it's also not a number any finance department shrugs off either. If Chinese chip makers like SMIC, Hua Hong Semiconductor, and Changxin Memory Technologies, all 3 of which are already confirmed as first customers for Aishengna's new machines according to Reuters, start redirecting even a modest percentage of their mature node tooling purchases away from ASML and toward a domestic alternative over the next several years, that revenue line doesn't collapse in 1 quarter. It bleeds slowly, predictably, and it shows up first in analyst downgrades months before it ever shows up in an actual earnings report, which is exactly the kind of slow compounding threat that keeps corporate strategy teams up at night far more than a single bad headline does. There's also a piece of legislative timing here that makes this whole story feel less like coincidence and more like an inevitable collision course. Back in April, U.S. lawmakers introduced a bill called the Multilateral Alignment of Technology Controls on Hardware Act, or the Match Act, specifically aimed at stopping ASML from shipping immersion DUV machines to China at all, closing what Washington viewed as a dangerous loophole in existing export restrictions. Sit with the irony of that for a second. The exact category of machine that American lawmakers were actively racing to cut China off from is the exact category China announced just months later that it can now build entirely on its own. If the timing feels less like a coincidence and more like cause and effect, that's because it almost certainly is. Years of steadily tightening export controls, starting well before this specific bill, didn't stop China's ambitions in this space. They simply forced those ambitions underground and redirected the money and talent toward building an alternative path. This breakthrough is one of the first major publicly visible results of that redirection actually paying off, and it raises an uncomfortable question for policymakers on both sides of the Pacific. If restricting access accelerates domestic development instead of preventing it, what exactly was the strategy buying, and for how much longer will it keep working? It's worth being honest here, too, about where China's success came from, because the full picture isn't purely a story of brilliant homegrown engineering triumphing against the odds, even though real engineering achievement is genuinely part of it. China's push into advanced lithography has run for years, alongside a documented, well-covered history of industrial espionage cases connected specifically to ASML, including former employees and business partners accused over time of attempting to move sensitive intellectual property out of the company's tightly guarded research pipeline. None of that history alone explains what Shanghai Aishengna managed to build, because actually operating a functioning DUV production line at meaningful volume, even one 4 generations behind the cutting edge, still requires enormous amounts of genuine engineering, talent solving, genuinely hard problems that stolen documents alone can't solve for you. But it's part of the complete, honest picture of how China arrived at this point faster than most Western analysts expected just a few years ago. Some of what happened here is authentic homegrown breakthrough. Some of it is the consolidation of scattered domestic startups that had been quietly grinding away with limited attention. And some of it almost certainly sits inside a longer, murkier history of technology transfer that the semiconductor industry has been watching and worrying about for the better part of a decade. There's a comparison worth making here too, one that people inside the industry keep bringing up, even if it doesn't always make headlines. Years before this DUV breakthrough became public, there was serious research activity inside Chinese semiconductor circles around an entirely different approach called localized dynamic patterning, an attempt to potentially leapfrog past traditional EUV technology altogether, rather than climb the conventional ladder toward it step by step. That effort had connections to names including Huawei and SMIC, and it targeted trial production with hopes of eventually sidestepping ASML's advantage entirely, instead of directly competing with it on ASML's own terms. That specific approach hasn't delivered the kind of headline-grabbing results the DUV consolidation just did, at least not publicly yet. But it tells you something crucial. China has been running multiple parallel bets on how to break this monopoly for years, not just one straight-line copy ASML strategy. Some of those bets quietly stalled or underdelivered. This particular one, built on absorbing existing startup talent rather than inventing something radically new, actually landed. The lesson isn't that China succeeds at every attempt, because clearly it doesn't. The lesson is that there have been far more shots on goal happening quietly behind the scenes than most people outside the industry were tracking, and eventually, with enough attempts running in parallel, one of them was going to connect. Let's also put some real numbers around what domestic tooling actually costs China right now versus what it saves them, because that trade-off is what determines whether this program keeps getting funded at the current pace or quietly slows down the way some past domestic chip efforts eventually did. Building out an immersion DUV production capability from scratch, even one riding on absorbed talent rather than starting from zero, still requires enormous ongoing capital. Cleanroom facilities, precision component suppliers, testing infrastructure, and years of iterative engineering before yields become commercially competitive. None of that is cheap, and none of it happens without sustained state backing, because private capital alone rarely tolerates the kind of multi-year, uncertain payoff timeline this technology demands. What makes this program different from some of China's earlier, less successful domestic chip pushes is that the demand side is already guaranteed. SMIC, Hua Hong, and CXMT aren't hypothetical future customers. They're named confirmed buyers according to Reuters, which means Aishengna doesn't need to win over skeptical private clients from scratch. It just needs to keep delivering machines that meet the bar its state-linked customers have already agreed to accept. That guaranteed demand is exactly the kind of cushion that keeps expensive, slow-moving industrial programs alive through the years when the technology still isn't good enough to compete on the open market. Compare that to what a similar bet would require in the United States or Europe, and you start to see why the story landed with such force outside China too. Western semiconductor equipment companies operate inside public markets that demand quarterly proof of progress, not 5 or 10-year patience for a domestic alternative to mature. If Applied Materials or Lam Research tried to fund a decade-long, low-margin effort to build a worse version of an already solved technology, shareholders would revolt long before it ever reached production scale. China's state-directed model can absorb that kind of patient, unprofitable runway in a way that publicly traded Western competitors structurally cannot. And that's arguably as important a structural advantage as any specific engineering breakthrough. It's not that Chinese engineers are inherently faster or smarter. It's that the entire incentive structure around this specific bet is built for a kind of patience that Western capital markets rarely tolerate anymore. So let's actually separate the panic from the substance here, because that's ultimately what determines whether this is truly ASML's worst nightmare or just a very scary Tuesday that fades from memory in a few months. The nightmare isn't that China matched ASML's technology this year. It clearly hasn't, and every credible analyst we've cited agrees on that specific point without much disagreement. The nightmare is structural, and it's about precedent. For nearly 2 decades, the entire Western strategy toward controlling advanced chip technology rested on the assumption that lithography specifically was an unbreakable choke point, a piece of engineering so absurdly difficult that no amount of Chinese state investment or industrial policy could realistically crack it within any relevant time frame, buying the rest of the world essentially permanent breathing room at the cutting edge. That assumption just took its first real publicly confirmed hit. Not a shattering blow, a real hit with real machines, shipping to real customers, running on a real production timeline that multiple credible news organizations have independently verified. The choke point turned out to be crackable, at least at one tier of the technology, faster than nearly anyone in Washington, Amsterdam, or Wall Street predicted just a year or 2 ago. And that changes the entire conversation about how much time the advanced tiers, EUV specifically, actually have left before facing serious pressure of their own. There's a psychological dimension to this too that doesn't show up in stock tickers but matters enormously for where this goes next. For years, engineers and executives inside China's semiconductor sector operated under a kind of quiet fatalism, specifically about lithography, treating it as the one link in the entire chip supply chain they might genuinely never fully control, no matter how much progress they made everywhere else in chip design, packaging, or manufacturing scale. Watching an actual domestic machine roll off a production line and ship to a real customer like SMIC does something to that internal psychology that no government subsidy program or 5-year plan on paper could ever accomplish on its own. It converts an abstract, distant national goal into a tangible, undeniable proof of concept that engineers across the entire industry can point to and build momentum from. That shift in confidence and morale inside an industry that runs on long-term, multi-decade research bets is arguably just as important as the machine itself, because it changes how much talent, funding, and political will gets poured into the next, much harder rung of the ladder, EUV. That shift also ripples outward into how the rest of the world's chip-dependent economies start hedging their own bets. Countries like South Korea, Japan, and Taiwan, all of which sit downstream of both ASML and China in this supply chain, are watching this development just as closely as Washington is, because a more self-sufficient China changes their own long-term positioning too. A South Korean memory maker or a Taiwanese foundry doesn't necessarily want to see Chinese competitors gain a cheaper, tariff-immune alternative supplier for their tooling, since that erodes one of the few structural advantages non-Chinese chipmakers currently hold in cost and access. At the same time, some of these same countries have their own reasons to want ASML's monopoly diluted, since a single supplier dependency has always made the entire regional industry vulnerable to price increases, delivery delays, or geopolitical disruption entirely outside their control. That's the quieter, less discussed layer of this story. It's not simply a 2-player match between Washington and Beijing. It's a multi-country recalibration, where nearly every major chip-producing economy now has to reassess how much of its future still depends on one Dutch company's factory floor. Which brings us to the actual question that matters more than anything happening in the stock market this week. The question every serious analyst covering this story keeps circling back to without a confident answer. Does this kind of momentum compound? Lithography is a field where each successfully built generation of tooling teaches engineers hard-won lessons that make the next generation, even a vastly harder one, somewhat less impossible than it looked before. ASML itself never jumped straight from nothing to a working EUV machine. It climbed a long ladder of incremental generations over literal decades, and every single rung mattered, teaching lessons that fed directly into the next. China just built its first real rung at meaningful production scale. The optimists inside China's semiconductor push will point out that's exactly how ASML's own journey started too, one imperfect generation at a time, until the imperfections gradually stopped mattering enough to hold the company back. The skeptics, and there are plenty of well-credentialed ones among the analysts cited throughout this story, will counter that DUV and EUV are separated by such a genuinely massive leap in optical physics, light source engineering, and precision manufacturing that successfully climbing one ladder doesn't automatically guarantee you can climb an entirely different, far steeper one, no matter how quickly the first climb went. What we do know, and what actually matters more than reacting to every headline every time a stock drops 7% in a single afternoon, is exactly what to watch for as this story develops over the coming months. Watch the real yield rates coming out of SMIC, Hua Hong, and CXMT once these domestic machines move past pilot testing and into genuine production lines, because a machine that functions correctly in a controlled lab environment and a machine that reliably produces usable, sellable chips at commercial scale are two very different engineering achievements, and the gap between them has killed plenty of promising technologies before. Watch whether Aishengna actually hits its stated production targets of 5 machines this year and 20 next year, because missing those specific numbers would tell us a great deal about how genuinely scalable this manufacturing breakthrough actually is versus how much of the current excitement is running ahead of the underlying reality. Watch what happens with the Match Act, now that the specific loophole it was designed to close appears to already be closing on its own through domestic Chinese substitution rather than through American legislation. And watch ASML's own language in its upcoming earnings calls closely, because a company with 2 full decades of hard-earned institutional knowledge about exactly how difficult this technology actually is will tell you, in careful, measured corporate language, whether they're genuinely rattled behind closed doors or whether this is mostly noise that's already fully priced into their long-term strategy. Because here's the thesis that runs quietly underneath nearly every serious analyst take on this story. Whether they lean skeptical or genuinely alarmed about China's trajectory, nobody in this industry ever seriously believed ASML's monopoly was going to last forever. The real, substantive debate inside the industry was always about timing, never about the eventual outcome. Export controls were never designed to permanently freeze Chinese semiconductor engineering in place indefinitely. They were only ever designed to slow it down and make the entire effort dramatically more expensive, buying the rest of the world years of relative advantage rather than the decades some policymakers publicly hoped for. What happened in the final week of July made one thing unmistakably clear. The clock on that buying time strategy is running considerably faster than most people in Washington and Amsterdam were comfortable admitting out loud. China didn't just build a machine. It provided the first hard, publicly confirmed proof that a door widely assumed to be permanently sealed can, with enough accumulated time, enough consolidated talent, and enough sustained state investment, be pried open at least part way. Whether that door eventually swings all the way open on the far harder EUV tier remains a genuinely open question, and it might honestly be the single most consequential open question hanging over the entire global semiconductor industry right now. So what do you actually think happens first here? China closing the real gap on EUV technology sometime within this decade, or Washington and its allies finding an entirely new bottleneck to lock down before that gap ever has the chance to close? Drop your honest take in the comments below, because this is genuinely one of those rare stories where the honest, unfiltered answer is that nobody actually knows for certain yet. Not the analysts writing the reports, not the investors who panic sold billions in market value last week, and not even the engineers on either side of the Pacific Ocean, who are already quietly working on whatever machine comes next.